Guys, today we're going to talk about equivalent expressions, and the I can statement is I can use my knowledge of the order of operations to create equivalent expressions. And really what we're doing is we're simplifying expressions. So today we're just going to talk about how do we combine some of those like terms, and we're going to review some of that vocabulary that we started before our break. So think about a trip to the grocery store, okay? Instead of selling apples by the pound, the grocer decides to sell them by the quantity. So each bag's going to have the same number of apples, for example. So how can we write an expression to describe 2 bags of apples when we don't know how many bags of apple or how many apples are in each bag? Well, let's look. We have 2 identical bags of apples. Each bag has the same number of apples. I don't know how many that is. So I have to write 2A, meaning there are 2 bags with a number of apples in it. I don't know how many apples that is. That's why I had to include a variable. The grocer does the same thing with bananas. Instead of selling them by the pound, he sells them by the quantity. So each bag is going to have the same number of bananas. So if I wanted to write an expression for 3 bags of bananas, and I don't know how many bananas are in each bag, I have to write 3B, meaning there are 3 bags with B bananas in it. I don't know how many that is. Pineapples are sold separately. So if we only wanted to buy 4 pineapples, we would just have 4. Notice there is no variable here because I know exactly how many pineapples I bought. Whereas with apples and bags, bananas, I didn't know how many fruits I had altogether. So let's go shopping. Your mom wants to make a fruit salad and she says she needs 2 bags of apples, 1 bag of bananas, and 2 pineapples. And being the helpful child you are, you decide to help her out. And on the way home from school, you purchase what she needs. So let's think about what you need. 2 bags of apples, 1 bag of bananas, and 2 pineapples. What would be an algebraic expression for the total pieces of fruit you purchased? Well, how many bags of apples do you have? How many bags of bananas do you have? And how many pineapples do you have? All right, your expression would be 2A for your 2 bags of apples, plus 1B for your 1 bag of bananas, plus 2 because you have exactly 2 pineapples. So your mom is super thankful, but your sister, she was also trying to be helpful too, and she bought all the fruit that your mom needed for the fruit salad as well. So how much fruit does she have now? Well, let's think about what you purchased. And your sister purchased the same thing. So altogether, what would be an algebraic expression for the total pieces of fruit at your house? 4 bags of apples, 4A, plus 2B for your 2 bags of bananas, plus 4 for your 4 singular pineapples. Try this one. Your dad, he wanted some fruit, so he bought 6 bags of apples and 2 bags of bananas. Your brother bought 2 bags of bananas and 2 pineapples. So let's write an algebraic expression for the amount of fruit they had all together. So your dad, he bought 6 bags of apples, 2 bags of bananas, 6A plus 2B. Your brother bought 2B plus 2 for the 2 bags of bananas plus 2 pineapples. Now, if I want to combine that, let's talk about what we have all together. How many bags of apples do we have? 6 altogether. How many bags of bananas do we have? 2 altogether. And how many pineapples do we have? 2 altogether. So if I were to combine that, I'd have 6A plus 4B plus 2. Now notice, I combined my 2 bags of bananas. Those are like terms. Remember talking about those? Terms that have the same variable raised to the same power. So I was able to combine them because like terms can be combined. Let's just do a quick review. A term is a number variable or product of a number or variable, like 2x, that are separated by plus and minus signs. So look here. Look at all the terms we have. Those are those things separated by pluses and minuses. So altogether, how many terms do we have? We have 5 terms in this expression. Remember the word coefficient. Coefficient is the number that's multiplied by an algebraic expression. So a variable itself has a coefficient of 1. So if it's just x, we know that there's that imaginary 1 in front of it. But looking here, we have 7x. 7's our coefficient, x is our variable. And like terms are terms that have the same variable raised to the same power. It's helpful when identifying them to use different shapes or colors to indicate like terms. So let's identify the like terms in this list because we're going to need to use that in a minute to simplify our expression. So what goes with 3t? 7t. What goes with 5w squared? 4w squared. And 9v and 8v go together. So our like terms are 3t and 7t, 5w squared and 4w squared, and 9v and 8v. So combining like terms is the same thing as grouping similar objects. So if I have 4 bags of apples and I want to add another 5 bags of apples, altogether I have 9 bags of apples. Now look at what happened with my expression. 4a plus 5a is 9a. All I had to do was add my coefficients. So when I combine like terms that have the same variable, you're either going to add or subtract the coefficients and keep the variable the way it is. So let's talk about what your mom has all together. You bought 4 bags of apples. You and your sister together got 4 bags of apples, 2 bags of bananas, and 4 pineapples. Your dad and brother got 6 bags of apples, 4 bags of bananas, and 2 pineapples. So what's an algebraic expression for the total amount of fruit your mom has? Well, let's think. Let's combine our like terms. 4a plus 6a equals 10a. 2b plus 4b equals, not 6, or 8, it equals 6b, and 4 plus 2 equals 6. So all together, your mom has 10 bags of apples, 6 bags of bananas, and 6 pineapples, and that's a lot of fruit. We are done with this video now. You can go back and watch any part as many times as you want, but don't forget to WSQ.